Hey Ramblers, this video covers chapter 12.3 in our textbook and deals with the surface area of circular solids. Now when we say circular solids, we're talking about cylinders, cones, spheres, and I've added hemispheres. So please take careful notes. There's going to be several formulas that you'll want to make sure that you get into your notes and then get onto that formula page that I hope you're keeping. You're going to see that cylinders are a lot like prisms. So those two formulas you should keep right next to each other in your notes. That cones are really similar to pyramids, so keep those notes together. And well, spheres and hemispheres are kind of a class on their own, so maybe you'd want to put those two together. Thanks for watching, and I hope this helps. Okay, let's start our discussion by looking at cylinders. From the diagram here, you can see that a cylinder is a lot like a prism. It has two bases, which instead of being polygons are circles. The bases are parallel, just like in a prism, and between the bases is kind of a congruent height that extends all the way around, but instead of being made up of parallelograms, it's kind of one circular region. Now, if we were to flatten out a cylinder into what is called a net, you'd see that the bases, when flattened out, are just circles, but this lateral region of the cylinder becomes flattened out and actually turns out to be a rectangle. Maybe we should compare the diagram right next to the net. And you can see that the height of the cylinder becomes one dimension of the rectangle, but then the length is actually the circumference of the base. So that's why it's represented as 2 pi r. So a cylinder has two dimensions, just height and radius, and when flattened out, the radius actually becomes part of this rectangular region, which makes up the lateral face of a cylinder. Alright, so if we take a look at the surface area of a cylinder, we can see that it is just like a prism, the perimeter of the base times the height. But since the base is always a circle, that perimeter can be expressed as 2 pi r, and the height is just h. So make sure you get that formula in your notes. The total area of the cylinder is equal to the lateral area plus 2 times the area of the base, just like a prism. But once again, since the base is always a circle, we can express the lateral area as 2 pi r h and the base as pi r squared. So it becomes 2 pi r squared. Make sure both those formulas are in your notes right next to the notes on prisms. Okay, let's move on then to the next circular figure, which is cones. Now cones, you'll recognize, are a lot like pyramids. This cone is inverted, its tip is at the bottom, but this is called the vertex down here, and then the height will run through the center of the cone, just like a pyramid. The slant height represents kind of the lateral edge of a cone, and then the base of a cone, rather than being a polygon, is always a circle. Okay, so there's three dimensions we need to be familiar with cones. For surface area, we're going to use the radius and the slant height, which is represented as L. So the surface area of a cone is broken up just like a pyramid into lateral area and total area. The lateral area of a cone is 1/2 the perimeter of the base times the slant height. Now because the base is a circle, we can represent that as 1/2 the circumference times the slant height. Again, circumference is 2 pi r, so when we multiply that by 1/2, we can really begin to simplify this formula to be the lateral area of a cone equals pi times r times L. If you don't see how I made that last step, pause the video and see how I went from 1/2 2 pi r times slant height to pi rl, because it's a really handy abbreviation of that formula. The total area is just the lateral area plus the area of the base, which is pi rl plus pi r squared. Okay, take a minute, pause the video, make sure these are in your notes next to your formulas for pyramids. Alright, let's move on then to spheres. Now spheres only have one dimension, and that's the radius. And the radius can extend in any direction from the center of the sphere to the edge. Now, we don't have the math needed to prove this formula to you, but the surface area of a sphere is simply 4 pi r squared. There is no lateral area because there is no base of a sphere. There are no lateral edges or anything that we associate with other things like pyramids and prisms. So please get this in your notes that the total area of a sphere is 4 pi r squared. All right, well then let's take a look at something closer related to a sphere, which is a hemisphere. A hemisphere is simply a sphere that's been cut in half, and when doing so, it created another plane. It created a base. So the surface area of a hemisphere is actually going to be made up of lateral area, which is 2 pi r squared. That's simply the surface area of a sphere cut in two. But the total area of the hemisphere includes a base which was created by splitting the sphere in two. So we have to add on the lateral area plus another pi r squared to represent the area of the base. That means the total area of the hemisphere is 3 pi r squared. So putting the two together, we have a total area of a sphere equals 4 pi r squared, and the total area of the hemisphere is 3 pi r squared. Okay, Ramblers, I'm going to give you a couple of examples in the tutorials. Please make sure all these formulas are in your notes, and I hope that you start memorizing them. Okay, thanks for watching, and I hope this helped. Okay, in this video we looked at the surface area of circular solids. So we looked at the surface area of a cylinder, which we broke into the lateral area and the total area. Now, recognizing that a cylinder really has the characteristics of a round prism, the lateral area was simply the perimeter of the base times the height. Now, the perimeter of a circle is 2 pi r. So the lateral area of a cylinder is simply 2 pi r times h. The total area is, like a prism, LA, or the lateral area, plus 2 times the area of the base. Now, once again, since a cylinder, the perimeter is the circumference and the base is simply two circles, the total area formula can be written as 2 pi rh plus 2 pi r squared. All right, then we looked at a cone and considered a cone as a round pyramid. The lateral area once is 1/2 the perimeter of the base times the height, which simplifies to the very handy formula pi times r times L, where L represents the slant height. The total area, like a pyramid, is just the lateral area plus the area of the base. Since the base is a circle, the total area simplifies to pi rl plus pi r squared. Then we looked at spheres and hemispheres. Now with spheres, there is no base, and there are no lateral edges or base edges, so we just have total area. And the mathematics is beyond the scope of this course to prove this, so you just have to accept this formula that the total area of a sphere is 4 pi r squared. And finally, we looked at hemispheres who have a lateral area. Because there is a base on a hemisphere, we do consider the lateral area and the total area of a hemisphere. The lateral area is 2 pi r squared, and the total area will include the circular base. So that simplifies to 3 pi r squared. Ramblers, thanks for watching. Hope the tutorials are helpful to you. Number 6 on page 573 asks us to find the total surface area of this cylinder that's been cut in half. So let's count up the surfaces and figure out the area associated with them. Well, first of all, we have 2 half circles. Those make up our base. And then we're going to have to add on the 1/2 of the lateral area of a cylinder. But then we also have to add on this rectangular region created by cutting the cylinder in half. So we'll just call that the rectangular region, or just the rectangle. Okay, I'm going to put in my dimensions now and calculate my area. So I have 2 times 1/2 5 squared pi, and that just gives me 25 pi. And then the lateral area of a cylinder is 2 pi r times h, so that gives me, when I multiply that by half, I'm left with 10 pi. And finally, that rectangular region is going to be 20. So my total area for this figure is 35 pi plus 20. Let's move on to number 10, which is another problem that gives trouble every year. Okay, number 10 has 3 figures. We have a cone at the right end of this solid, a cylinder in the middle, and a hemisphere at the end. But we only need the lateral area of the hemisphere, the lateral area of the cone, and the lateral area of the cylinder in order to calculate this. Because the bases of all 3 were covered, we can't get at this circular base of the hemisphere and this circular base of the cone. They're covered by the cone, they're covered by the hemisphere. So we're just going to add up the lateral area here. The lateral area of the hemisphere is 2 pi r squared plus the lateral area of the cylinder, which is 2 pi r h, and the lateral area of the cone is going to be pi r l. Well, the radius for all of these is 3, because that's half of the diameter that is given of 6. So be careful, because that radius of 3 means that the radius of the hemisphere is 3, which means the height of the hemisphere is 3. So when I try and calculate the height of the cylinder, I can subtract off the 3 from the left end, and I can see that if this has a slant height of 5, and I know that the radius is 3, by triples I know that the altitude of the cone is 4, so I can subtract that off as well. So that means that the height of my cylinder is going to be 17 minus 7, or 10. And then I'm going to add on the lateral area of the cone, which is pi times 3 times the given slant height of 5. All this works out to be a total of 93 pi. Okay, there's still 2 more that I want to look at. 12 and 13 are important problems as well. Number 12 is a square-based prism, where the bases are not on the bottom where we usually expect to find them, but I'm saying this 8 by 8 square end is the base, and a hole is made through the entire prism. And when you made the hole, you removed some surface area, this circular surface area, from both bases, but you also added all the surface area in the interior of the hole. So imagine going through a tunnel. The tunnel has sides which have surface area, which we have to include. So to figure out the total area of this figure, we have a lot of components, some of which we add, some of which we subtract. So let's go through them. So the total area will be made up of the lateral area of the prism, plus the 2 bases of the prism, but then we're going to have to account for the 2 holes that we drilled on through from one end to the other. But when we made that hole, we added some lateral area in the middle. So now we have to put the dimensions together and calculate that. So the lateral area of the prism is the perimeter of the base, 8 plus 8 plus 8 plus 8, which is 32 times 10, giving us 320, plus the 2 bases, which are 8 by 8, so that's going to give us 128, minus the 2 circles. So 2 times 9 pi is 8 minus 18 pi. And then we're going to add on the lateral area of the cylinder, which is 2 pi times 3 times the height of the prism, which is 10. All right, adding all that up, we get 448 plus 42 pi. Okay, let's take a look at one more because it's a tough one. So let's look at 13. Okay, number 13 on page 574 introduces us to a frustum. And a frustum is a cone that has had the top chopped off, leaving us with something that looks like a lampshade, or people have said it looks like the thing that elephants stand on in the circus. Well, the secret to figuring out the total area of a frustum is to bring back that cone that was chopped off, because figuring out this lateral area is very difficult. So we have to do it by taking the lateral area of the whole cone, or what I'll call the big cone, and subtracting the lateral area of the top cone, because we have formulas for areas of cones. And then we have the relatively easy task of adding on the two bases, which we have are just circles. So the lateral area of the big cone is going to be this cone here, that if we were to draw it back in, you could see that we can figure out the dimensions through similarity. So if I set up a proportion that x is to 4 as x plus 5 is to 8, I can solve that to find that the slant height of the top cone is also 5, which means the lateral area of the big cone is going to be pi times the radius of the big cone, which is 8, times the slant height, which is going to be 10. Then I'm going to minus the lateral area of the top cone, which will be pi times r times the slant height of 5. And then I'll add on the two bases, which are just going to be 4 squared pi plus 8 squared pi. So, adding up all these parts gives us 80 pi minus 20 pi. But then we're going to add on another 80 pi for the bases, giving us a total of 140 pi for the total area. Okay, Ramblers, this one's a tricky one. Make sure you know how to do it. It'll probably show up in a quiz, as will number 12. Okay, thanks for watching.